Hello, and welcome back to Summarize Science. Today, we're looking at a fascinating paper that introduces a method for large language models to essentially teach themselves. You know that AI models are incredibly smart, but they have a problem. To become experts in specialized fields like medicine, they usually need huge amounts of expert-level training data. Getting that data can be difficult, especially in fields with strict privacy concerns. This paper proposes a clever solution to get around that problem. The researchers realized that for centuries, human experts have been creating ontology rules, which are basically just formal rules of logic about how concepts relate to one another. A simple example is, if a poodle is a type of dog and a dog is a type of mammal, then logic dictates a poodle must also be a type of mammal. The big idea here is, can we give an AI a few of these powerful, common-sense rules and have it check its own knowledge for mistakes? This is where their framework, called Evontree, comes into play. First, they prompt the AI to generate a tree-like structure of what it already knows about a topic, mapping out subclasses and synonyms. Then, they use just two core ontology rules to comb through the AI's own knowledge map and search for inconsistencies. It's like giving the AI a logic checker to find contradictions in its own thinking. When Evontree finds a piece of knowledge that the AI should know based on logic, but doesn't seem confident about, it flags this as a knowledge gap. These gaps are essentially the AI's blind spots. The system then automatically creates new question-and-answer training examples specifically targeting these gaps. So, the AI is literally generating its own homework to fill the holes in its knowledge. So, how well did it work? The researchers tested Evontree on several difficult medical question-and-answer benchmarks. The results in this table show that the models improved with this self-training method consistently performed better than the original models. Even on an AI model already fine-tuned for medicine, the Evontree method was able to boost its average accuracy by a further 3.7%, which is a significant improvement. Here's a great example of it in action. A medical question asks where a certain type of tissue fiber is found. The original base AI model gets the answer wrong. However, after being fine-tuned with Evontree, the model has learned the subtle biological distinctions from its self-generated training data and now answers the question correctly. So let's recap the key takeaways. The Evontree framework allows an AI to improve its specialized knowledge using a small set of logical rules without needing massive external datasets. It works by extracting the AI's existing knowledge, using rules to find its logical blind spots, and then creating new training data to teach the AI what it missed. This process is a form of self-evolution, where the model audits and refines itself. What could this mean for the future? This approach could be a game-changer for deploying expert AI in fields where data is scarce or private, like healthcare, finance, or law. It's a big step towards more efficient, robust, and self-correcting artificial intelligence. Thanks for watching Summarize Science.